Is an important topic. So today at Planet's weekly webinar, we are going to talk about probably the mode of variability, the thing that determines predictability in the Earth system that many folks have not heard of, and yet is probably the most important predictor of subseasonal volatility. So today we'll be going into more detail on this. And before I get started, I'm going to introduce myself. So my name is Dr. Hansi Singh. I am CEO and founder of Planet AI. I have spent time as a scientist at the US Department of Energy. I've also spent time as a professor in academia. I'm an Earth system scientist. I got my PhD from the University of Washington here in Seattle. And my co-founder and I, we decided to start this company because we really wanted to bring state-of-the-art environmental intelligence from the research world to the real world to help real folks make decisions, especially given the fact that our planet is changing in many ways. And so that means that information becomes even more critical for decision making to avoid negative impacts or to minimize the negative impacts of those changes. So to get started today, what we'll be talking about is, first of all, what is the MJO, the MJ who? We'll be talking about impacts and global teleconnections associated with the MJO. We'll talk a bit about what modulates the MJO, why sometimes it's incredibly important, and why sometimes it's like, not a big deal. And then we'll talk a bit about the MJO currently in the forecast for the next 4 to 5 weeks. So let's dive right in. So first, what is this mode of variability that is supposedly important and that most people have not heard of? So the MJO is a slow-moving pattern of storminess that moves eastward over the tropics. And so what I show here is this kind of video of the tendency for precipitation over sort of a tropical region, though really this is extending quite far north and south. And you can sort of see that the areas of where precipitation is favorable and where they're unfavorable, they kind of very slowly are moving eastward. When I say slowly, it's taking like over a month to move all the way from one side of the Indian Ocean all the way across the Pacific. So this pattern of storminess moves from East Africa over the West and East Indian Ocean, over Oceania to the West Pacific, to the East Pacific, and even impacts specifically South America. So it's a huge global phenomenon, and yet it is something that often we don't think about when we think about predictability over these time horizons, at least for most lay folks. So what is the MJO specifically? So it is a slow-moving atmospheric wave system with a 30 to 60-day periodicity, usually more like 45 days, though recently we've kind of been seeing it stalled in various phases. This is probably something that some experts are going to be writing papers on in the near future, just the fact that it's moving so slowly. But generally, you can expect that it'll sort of make its trek across all of, basically over 2/3 of the planet around the tropical belt, approximately every 30 to 60 days. It goes through 8 different phases. And the reason why these phases are sort of important to look at here, I'm showing the precipitation anomaly associated with each phase at, I believe that this is kind of in the winter and the spring. And so these phases are each associated with distinct teleconnections. And when I say teleconnections, what I mean is that this pattern of storminess that's sitting in the tropics actually has long-ranging impacts on the circulation over North America, South America, even some areas in Western Eurasia. And this is through atmospheric and oceanic energetic waves, not the ocean waves that you're used to, but different forms of waves that move through the atmosphere and the ocean. So, as we mentioned, the MJO impacts temperature, precipitation, winds, and other environmental variables around the world through teleconnections. So what do we mean by these teleconnections? So here's one example. So right now we are in a very strong MJO phase 7, And these are the teleconnections associated with it. So from where the convection is sitting, so sort of east of Oceania, we get these really cool sort of wave trains. These are called Rossby wave trains, and you can see that they're sort of moving northward and then over North America. And this, in fact, gives rise to what we call a positive PNA pattern. And so this is actually helping to contribute in some way to this cold snap that we are currently seeing this week. It is not the only cause. Remember, we've talked about how it's that polar vortex weakening that brings on these cold snaps, but it is a contributor that helps intensify the cold snap. And then you can see that it actually affects the NAO all the way on in the Atlantic. And so that, in effect, will impact to some extent what is going on over Western Eurasia. So just huge, far-ranging global impacts associated with this mode of variability. And please keep in mind that these impacts vary by the time of year, as well as other modulating factors, which we'll get into more in some coming slides. So the beauty of the MJO is that it is very predictable. It is very predictable, usually 30 days up to 40 days. There is some evidence that as our planet warms, it is actually going to become more predictable. So that is kind of exciting. Usually we don't talk about the benefits of our warming planet, but here we are. And it also, in order to predict it well, requires a very robust Earth system modeling framework. So when I say robust, we need amazing cumulus cloud parameterizations, good stratospheric processes to sort of create those huge convective towers, and we need good ocean feedback. So you really need a comprehensive Earth system modeling framework to model this and its teleconnections well. And so, because this mode of variability is so predictable and so far-reaching in its teleconnections, the MJO phase is just a really key global predictor of weather conditions beyond your 14-day weather forecast. So, from 14 days to 40 days, the MJO is where you want to be looking to understand what to expect. So, I'd like to review some of the factors that the MJO can really help us predict well. So the first thing is, of course, this is a mode of storminess that occurs over the tropics. And so, of course, precipitation over the tropics, particularly monsoonal precipitation over the tropics, is predicted and modulated very well by the MJO. So this includes over East Africa, over South and Southeast Asia during their monsoon season, Brazil, Mexico, and Central America. So this is just an excellent predictor for tropical precipitation over that subseasonal time horizon. In other words, beyond that 10-day forecast, all the way up to a few weeks. Furthermore, we can also predict warm and cold anomalies over North America, and some of these can additively contribute to cold snaps that we see, particularly those due to polar vortex weakening events, and which we're seeing this week. Furthermore, we can also get a really good understanding of atmospheric rivers over Western North America through the MJO. And we can also understand precipitation anomalies over the southeast and Gulf Coast of the US because the MJO helps modulate moisture transport over those regions. So let's take a look at these in slightly more detail. So these are the global precipitation anomalies associated with phases 1 through 8 of the MJO in December, January, and February. And you can see that at this time of year, there is some great MJO signal, particularly over Australia, which is always exciting, right? Because this is an area that there is a lot of mining infrastructure, a lot of transportation, agriculture going on. And so, yeah, we get very good predictability at this time of year over that region. In other times of year, you'll see these precipitation patterns being shifted northward, and they're going to be much greater over southern Eurasia. And so that is those monsoonal circulations that we're talking about. The MJO modulates the monsoon quite beautifully. You might also notice in these figures that another area that it modulates really well in the tropics is Brazil. So we will talk about that closer to the end of this presentation as we look at the current MJO outlook. So cold snaps over North America, I know, are very important to a lot of folks, particularly from an energy perspective, potentially also from an agricultural perspective. So, cold snaps over North America are associated in particular with phases 7 and 8 of the MJO. These tend to produce colder than usual conditions over the continental US. Phase 8 in particular tends to produce a positive PNA pattern, which is kind of this half and half warm and cold pattern that we tend to see over the US. And so the impact of these phases, as we mentioned earlier, can really add to stratospheric driven cold snaps during weak polar vortex events. So now, what about precipitation over North America? Well, the MJO, it turns out, provides some really good predictability for atmospheric rivers over the American West Coast sometimes. Okay, so this is where the MJO, its strength and its teleconnections are highly modulated by other factors in the Earth system. And so, in particular, for atmospheric rivers over California, there are some times of year and some phases of variability where they are very predictable. It turns out this is this area that's lit up in this figure, and this is from Castellano et al. 2023, who have, I think, worked closely with the California Water Board to try to get some handle on what likely California precipitation is at the beginning of the year. It turns out that when we have an eastward QBO, in other words, the QBO is in its negative phase, and when it's late winter and early spring, so that's what these boxes represent, we actually have quite good predictability over many different areas of California for atmospheric river tendencies, particularly several weeks out. So these present forecasts of opportunity. And when we say forecast of opportunity, what we're saying is that these aren't predictable all year, but at certain times of year and at certain phases, particularly of the QBO, we have good predictability for precipitation over California. So before we move further, it's really important to say, well, what can the MJO not predict well? So the MJO is not magical, and basically anything beyond 40 days of lead time, you don't really want to be looking at this thing. It, more or less will sort of devolve into a climatology. And so generally speaking, 40 days is sort of the upper limit on what you can expect for predictability. It's also important to remember that the MJO is not always strong in amplitude. When it's very weak in amplitude, like its teleconnections are going to be weak, it's only going to have a very small influence on, say, weather patterns over North America. So just keep in mind, when the amplitude is large, it's a great predictor. When the amplitude is small, it is going to be much less useful in terms of its predictive power. Finally, in terms of conditions over Western Eurasia, if you remember some of those maps that I showed earlier, beyond tendencies in the NAO, generally speaking, the MJO influence is pretty strong over North and South America, but weakens substantially once you move over Europe. So that's important to remember that conditions over Western Eurasia, you want to look at other factors when you're looking at the subseasonal outlook. So what factors modulate the MJO? So we sort of got a peek at that earlier when we talked about how it was different by seasons and how when the QBO is in a certain phase, then West Coast atmospheric rivers are nicely predicted. So modulators of the MJO particularly include the QBO, include the El Nino index, and includes the seasons. So in particular, the MJO tends to be strongest when the QBO is in a negative phase like it is now. So here is where we are right now, looking at some upper wind measurements over the tropics. And so we are at a negative QBO. We're going to be at a negative QBO over definitely over the next 6 months. And so, yeah, we're in a great time for a strong MJO. The MJO, it turns out, is also more effective at propagating signals around the world when the El Nino index is neutral or negative. And so this is the situation we have now. So once again, that favors a strong MJO. It turns out also that in northern hemispheric winter or spring, that is also when the MJO is the strongest. And so right now, it is a great time for using the MJO for seasonal predictability because essentially, like all of these factors are more or less present. We just are in a really great time for being able to use the MJO for looking at subseasonal predictability. So now I'm going to move into the current outlook for the MJO. And before I do that, I just want to say a little something about weather forecasting beyond your 10 or 14-day weather forecast. So in general, for your weather forecast, up to 14 days, we use weather models, which are primarily atmospheric models. So these are really complex models. We run them on supercomputers. Recently, AI models have also shown themselves to be quite effective at this time horizon in terms of predictable power. But these are, as I said, complex models, but only of the atmosphere. In order to predict anything beyond 14 days, we really need this more complex modeling framework known as an Earth system modeling framework. So in this framework, we not only have the atmosphere as one key and important component, but also the ocean, the land surface, and the ice. And what that means is that these other components of the Earth system allow us to extend the predictability of our forecasts well beyond 14 days. So the deep ocean, for example, has an insane amount of long-term memory, hundreds of years. But definitely the surface oceans, this is what allows us to predict factors sub-seasonally and seasonally, and the land surface as well can help us extend predictions for weeks to months into the future, as well as the ice. So it's really important to remember that with this kind of forecasting, we can't tell you, for example, will December 25th be snowy at your particular location, but we can tell you something like, will the week of December 25th have a greater than usual likelihood of cold weather conducive to snow? So it's a powerful type of forecasting, but it is not a day-to-day type of forecasting when we get beyond this sort of 14-day window. So the current state of the MJO. The MJO is currently extremely strong and it is in a phase 7 and it is moving into a phase 8. And what we believe is that particularly it has sort of helped reinforce the polar vortex driven cold snap that we currently see over the US and Canada. And that next week, as well as it sort of is moving into this phase 8, that it is going to reinforce some cold weather, particularly over the eastern seaboard of the US. And so, okay, let me move further. Yeah, this is okay. There goes the video right there. So that is this week, and then that is next week. And so these are the temperature conditions at this time of year associated with the MJO phase 7s and phase 8. So what is the MJO going to look like over the next few weeks? So the most likely scenario here is that the MJO is weakening over the next few weeks, and it is certainly by next week we'll have moved into a phase 8. So it'll be moving into a phase 8 and it will be weakening in intensity throughout the month of December. So given these factors, what can we say about predictability, say at week 3 or week 4? So here we're looking at North America and Central America 3 weeks into the future, so through mid-December. And these patterns actually look very MJO-like. So, specifically MJO phase 8-like. So, we see sort of drier conditions over the American West Coast and also over the Southeast. And then, interestingly, we see this really nice sort of band of Gulf precipitation over the central US. And so this looks very MJO-like. And in particular, too, we see wetter than usual conditions over Mexico and Central America. So yeah, this is like, not textbook, but it is a very MJO phase 8 at this time of year type pattern over the US that is appearing in our forecasts. Over South America, conditions are super interesting from the MJO perspective. So, couple of stories to tell here. Um, Colombia has experienced a ton of precipitation over the last few months. And for the next month, we are continuing to have wetter than usual conditions over coffee growing regions in this country. And that is significant because obviously that has implications for coffee prices. Generally speaking, coffee likes rain, but not too much rain. And it is possible that this is going to impact their harvests coming up over the next few months. So, definitely a region and a part of the market to keep in mind. Um, Also, over central Brazil, we're seeing this really South Atlantic convergence zone type pattern that, has been really popping up over the last few months as well. And I just want to highlight this area of central Brazil that includes Minas Gerais, where there's a ton of iron ore mining and where there has been higher than usual precipitation over the last several months. And so this is another region that is kind of going to continue to get hammered even near the end of its wet season. And so, probably something to keep in mind when you're thinking about the productivity of some of that ore extraction over that region. And so, this brings me to my last slide, which is thank you so much for being here. I'm happy to stay to answer any questions. If you have any kind of further forecasting needs, please feel free to get in touch with me. I'm on LinkedIn or through our website at planet.ai. And for next week, we're going to be speaking particularly about hydrologic cycle volatility on our warming planet and what the forecast has in store around the world. So excited to go into something that is near and dear to my heart, which is the hydrologic cycle. So thank you so much for being here and happy to take any questions. Yeah, so we have this one question regarding whether the current MJO forecast can indicates notable risks and opportunities. So the one area that I, did highlight here is this sort of pattern in South America. And, one of the other interesting details about this pattern in South America as well is that there is also a lot of mining that happens in this northern area of Brazil. And this area is a little bit drier than usual this year. And once again, this is an area where we've seen this pattern sort of persisting over the last several weeks to months. And so, this could be an area where if there is sort of some ore extraction going on, that you might see some interesting knock-on effects in terms of the supply chain. So, another area to keep in mind, in addition to the coffee and to the iron ore extraction over here in central Brazil. Yeah, thank you for that question. Ooh, another question. Yes. So we have the question about harvesting MJO predictability from modulations by other climate modes. So I mean, look, like we're in a strong QBO phase. QBO is insanely predictable, right? So we know, for example, that yeah, it has this kind of 22-month cycle. Dr. Aiden is on the call as well, who is a stratospheric expert. So of course he can talk a bit more about that. But I mean, the QBO is something that you can see a mile away. Is that right, Dr. Aiden?
Yeah, exactly. So when you have Easter, so thanks so much, Kai, for your question. And I think that your head is in the right spot here. One of the sad things about doing these predictions with traditional climate models and weather prediction systems is that they don't capture the connection between the MJO and this much longer timescale predictable phenomenon, which Hansi is referring to as this QBO. So, because the models themselves don't include that connection, but we know it exists in the real world, if we want to get the skill out of that, then we have to do some kind of like boutique fix to actually get that skill in there. So, you can do that using linear regression models or something fancier like an AI weather model, which may be able to capture those connections between these different modes because they're learning from historical data as opposed to the physics that we input into these traditional models. So, besides, I think your intuition here, which is by, doing this in kind of like a precise way of going in and actually adjusting their predictions based on what the phase of the QBO is for the NJO, there's not a one size fits all type of prescription for including this information. Does that kind of make sense though, Kai?
Yeah, yeah, that makes sense. Yeah, thank you for the
Yeah,
answer. By the way, I really
of
enjoyed it.
course. Yeah, so Kai is actually an expert in the MJO as well. So it's great to have you and see you here listening in.
Yeah,
Nice.
thank you.
Yeah, thank you so much, Kai. Really, really appreciate that question. All right, we are about at time. You know where to find us. We'd love to continue the conversation with folks that are interested in further long-range forecasting topics. If you have ideas for more webinars, let us know because we do these every week. And if there is a topic that you're just like, I really want them to explain this, please let us know because we will explain it. And we love doing things like that. So, thank you so much. Have a great rest of your day, and we will hopefully see you again next week where we talk about the hydrologic cycle. Take care. Bye.